Right. Essentially, what you do is you're given a series and you find another series called sigma bn that is like the original, right? We do the surgery so it looks like it. And then we find the limit of an over bn. And as long as that's a number that's not 0 or infinity, as long as it's a number 2 or 22, don't care, then your series, the original, behaves the same as the other one. And that's pretty much how the limit comparison test works. So let's look at this fella here. It's a version of 5. So we're being asked, does this converge or diverge? So I'm going to do some surgery on this fella here. And the idea of surgery is that you try and reduce it to, when they look like this, don't you try and reduce them to a p-series, right? So when you have two things on the top, pick the biggest, in this case, n, not much, that's pretty obvious. And this guy here is better written as 3/2. Are you with me for that? 3/2. Now, I can simplify by basically, reducing a 1 power. Are you happy that that guy behaves like this guy? Are you comfortable with how I got from there to here and then simplified finally down to there? Isn't it a bit like top power, take away the bottom, and you got that? Now, that's a p-series, which most of the ones you've seen, in fact, all the ones you've seen so far are. That's a p-series. Would you give p as a half? And p is less than 1. So what does that tell me about the comparison series? That's this guy. Converges or diverges?
Diverges.
Diverges. So technically at this point, couldn't you just hit the little dot that says diverges? But we have to prove it, right? And it's good practice to prove it, because you're going to have to prove it in your midterm, you're going to have to prove it in your final. So what we now do is we do the limit as n tends to infinity of an over bn. And an is that guy, and bn is the comparison guy, right? And that's never pretty, because they just aren't. The top guy is n plus 9 over n square root of n. And the bottom guy is 1 over n to the half, which I'm now going to call square root of n. Now, you shouldn't leave that like this and try and do any limit as n tends to infinity. Would you agree it's just not going to end well? So what you should think about doing pretty much every time is leave the top one alone and then multiplying by its reciprocal. So that guy becomes this multiplication. Are you comfortable about dividing is the same as multiplying by reciprocal? Right. Now, you should, if things work out well, shouldn't you be able to get some kind of cancel? Or at least a reduction. And now we have the limit as n tends to infinity of n plus 9. This looks very deja vu, so I may have actually done this question, or at least one like it. Okay, what is the limit of that fraction? It's pretty easy to do in your head. What is it? As n tends to infinity, what's the limit of this fraction?
1.
1. Now you can do it, for instance, by doing L'Hopital and differentiating top and bottom. There's your 1. I could, however, couldn't I have done it by dividing the top and the bottom by n and still got 1? So you pick whichever one you like, but the limit is 1. And we are pretty much finished. I'll have to kind of squeeze my answer in there. Didn't this guy, the comparison series, diverge? Hasn't the limit of these equal to 1? So by the limit comparison test, doesn't this guy, the original one, behave like that one? So we can now say that it diverges. And that is the limit comparison test from start to finish. That's all the pieces that you would typically need. Are you comfortable with that one? Does it have a flow to it? Right, let's move on and do another one with powers and then show you a different kind of limit comparison test, because there is another one that you can get as well. This one is similar to question 8. And for some reason, I've decided to use K, which is fine. We can use anything they like. And I'm getting some background sounds here. So there we go. So we have this guy, we have this guy, and we have this one. Right. So I'm going to take my guy, which is this fella, and do some surgery on him so that I can get a P-series comparison. Okay, what will we call the numerator here? What should I write down for the top?
K to the third.
Yeah, cube root. But it's a good idea to turn it into fractional power. What about the bottom? That's a bit of an interesting combination. What would I do for the bottom?
Would it just be K because it's the cube root of K to the third?
Yeah, and I'll put that one in as an extra line, but you don't need that extra line if you don't want it. That's Kira didn't. Now, that guy is not there, but he's darn close to being there, isn't he? He's darn close to being a P-series. But to be a P-series, don't you have to be 1 over K to the power of somebody, right? What fractional power do you get when you simplify this fraction?
K to the 2/3.
And would you agree that's now a P-series, which is what we're after? And that the P-series in this case is 2/3. And that is greater than 1. So that's yet another diverges. So far, so good. Now, what's about to happen next is very ugly algebra. It's not I'm changing the process, it's just ugly. So we're now going to do the limit and call it K of the top guy, which is this fella, divided by the bottom guy, which is this fella. And I'm not going to call it 2/3. I'm going to call it the cube root of K squared. And I forgot it's 1 over. Yes.
So how exactly would 2/3 be greater than 1?
Sorry, it isn't. It's less than 1, but it diverges.
Yeah, okay.
I just put that deliberate mistake in to check if Jade was paying attention. Matthew knew it was a mistake, but he's that used to me now, he doesn't even bother about it, right? Okay, but you're quite correct, Jade. It's good to point out because not everyone would have seen that. Okay, this ugly fraction is going to become a little bit less ugly, but not by any great amount. And so that's the top guy. Times, well, 1 over the cube root becomes the cube root over 1. So far, so good. This guy doesn't really cancel, or at least I wouldn't choose to cancel it right now. Has anybody got any suggestions about how to combine these fractions to make it just a little bit nicer, because right now it's horrendously ugly. In particular, is there any way to combine those two?
Okay.
Yeah. Cube root of k times the cube root of k squared. Doesn't that become the cube root of k cubed? And isn't that k? Agreed? And I'm not going to call it k, although typically I would. I'm going to leave it as that fellow. And the reason I'm leaving it as a cube root is that I want it to play well with the other cube root, right? I want to keep things kind of the same look. That way they can combine them a little bit better. I am now going to take both those cube roots and do that. Are you comfortable with two cube roots could be replaced by a single big cube root?
Yeah.
Right? Now what I'm going to do, there's a lovely rule in limits that says if you're finding the limit of an ugly guy, you can sometimes pull out part of the ugly guy. And by that I mean, I can now do the cube root of the limit as k tends to infinity of that. In other words, I switch the order in which we do things. So I'm going to do the limit first and then the cube root of that answer. So that is allowed. Now, why is that helpful? Forget about the cube root for a minute. What is the limit of this fraction? It's not actually that hard to do. What's the limit of k cubed over k cubed plus 9k plus 1?
1.
Just 1. So won't the answer be cube root of 1, 1? And we are pretty much done. Haven't we shown that this guy behaves like that guy and that that guy is divergent? And we've done that because the limit of the ratios is a number. So by the limit comparison test, this guy diverges. Right, a lot going on in there, but it was really just ugly algebra, right? I'm not changing what we did. It's just it was ugly things to do it to. Any questions before I move on to the next kind of limit comparison test? Okay. Let's do a limit comparison test to a geometric series. I'll put none. Suppose you had n equals 1 to infinity, 3 to the n over 1 plus 5 to the n. Now that's not a normal geometric series. This guy is in the family of geometric series. In other words, he behaves very like them, but it's not a geometric series. Wouldn't a geometric series be 5 times 3/5 to the power of n or something, right? That kind of look. But we're going to take the same idea, and that is, let's do some surgery on it. Now, when you do, oh, let me make this a little bit more interesting there. When you do surgery on series that have 5 to the n's in them, right, 2 to the n's, things like this, things that have got geometric series bits to them, the rules change a little bit. You can only have one guy in the top. It's either 3 to the n or it's a 2 to the n, and you always pick one particular one. What do you think the rule is in this case? What should I leave on the top row? Agreed. Why would you pick 3 to the n? What was the reason?
Bigger.
Bigger. You pick the most important, the bigger term. Isn't n cubed bigger than n squared? Right, for large values of n, isn't n cubed bigger than n squared? And so we pick the biggest, right? Now, on the bottom, right, this fella here, you also pick, technically, and the biggest, don't you? Would you agree in this case it's 5 to the n? Would that look right? Now, if I rewrite this guy, which I am, like that, do you see a geometric series now? What is the R value of this geometric series? Okay, it's 3/5. Now, the absolute value of this is less than 1. Is this a converging geometric or is it a diverging geometric? If the R is 3/5, does it converge or
converging.
it's converging because the absolute value of that. So we kind of know the answer already. Don't we know that this guy's going to converge because it behaves like this one does? But now we go to prove it. So it's going to be the limit as n tends to infinity of this guy divided by this guy. And I am going to write them in that form. And I'm going to do that little algebra trick, pretty much guaranteed to do that in all these questions, where you leave the numerator as it was, and you turn this guy upside down. Okay, now what's the math of this going to look like? Well, it's going to be a little bit ugly. I am going to distribute the 5 to the n with these two. And it works, I mean, it works in a way that makes sense to me at least. 3 to the n times 5 to the n gets me 15 to the n. 2 to the n times 5 to the n gets you 10 to the power of n. Are you happy about those multiplications, or would you like to see why I got what I got? 3 to the n times 5 to the n is 15 to the n, and 2 to the n times 5 to the n is 10 to the n. Does that seem reasonable? Okay. Now, if you go on the bottom, 3 to the n times 1 gets you 3 to the n, and 5 to the n times 3 to the n gets you 15 to the n. So basically what we now have is a rather weird looking fraction with various powers to the n, right? And can I tell you right now that the only two techniques that you have got are L'Hopital, actually 3 techniques: brute force, L'Hopital, or divide top and bottom by something. Brute force doesn't work. You get infinity over infinity. L'Hopital doesn't work because if you differentiate any of those guys, doesn't the answer get even uglier than it is right now? So by a process of elimination, the only thing we've got left is that we have to take this guy and divide the top and bottom by something. So we're going to adapt a technique that we used when it was n squareds and n cubes. Remember, you divide top and bottom by n, or n squared, or n cubed. I am going to divide the top and the bottom by one of these 4 guys. But only one of them is the right one to do. If you pick the other 3, nothing good happens. So which of these 4 terms will you divide the top and bottom by, do you think?
Wouldn't you have to do 15 to the n so it cancels those ones out?
Yeah, and so isn't the rule pick the biggest of the choices? Isn't that the same rule when you've got n cubes and n squares? Don't you always pick the big one, right? The n cubed. Remember that rule? When you divide top and bottom, pick the bigger power if you have to choose. So 15 to the n. Let's see what that looks like. Well, it's going to be the limit as n tends to infinity. If you divide this by 15 to the n, you get 1. If you divide this by 15 to the n, you get 10 15ths to the n. If you divide this by 15 to the n, you get 3 15ths to the n. And if you divide this by 15 to the n, you get 1. Are you happy about where these two fractions are coming from? Right, let's do brute force. 1 plus 10 15ths to the power infinity, 3 15ths to the power of infinity, plus 1. Okay. If you take any number that's less than 1 and you raise it to the power of infinity, don't you get 0? Like a half to the power of infinity, a quarter to the power of infinity. You get 0. So 1 plus 0, 0 plus 1. Bingo. Then we get a limit of 1, a number. And according to the limit comparison test then, since this guy behaves like him, and this geometric series converges, so does our guy. It has a lot of similarities with the n squared plus 1 over n cubed plus 1, right? It has a lot of similarities to that. But would you agree the algebra is a little bit different? You know, you have to deal with it in a slightly different way. Are we okay with that question? This is why I need pictures. Okay, I will assume that since no one is unsure. Let's find one of those guys to do. It's always the best thing to try it.
6.
Yeah, you're right, 6. N equals 1 to infinity, 9 to the n, 1 plus 14 to the n, right? Okay, I'll do the surgery on this one then. Really no choice, because there is only one guy on the top. And would you agree there's really only one choice on the bottom? And so this is essentially that guy. And that's a geometric series. And R is 9/14. And the absolute value of R is less than 1. So this thing converges. And now what we're going to do is proof of it. So the limit as n tends to infinity of that guy divided by that guy, which becomes the limit as n tends to infinity of, leave the top one alone, and multiply by the reciprocal. And no two questions are always identical. Would you agree that we got lucky here and we can do a cancel? What can I cancel?
9 to the n.
Yeah. I mean, if you see it, go for it. Would you agree it's just going to make my job a little bit nicer, right? Just a little bit. And so we now are looking at 14 to the n over 1 plus 14 to the n. And aren't we going to do that divide top and bottom by somebody trick? I don't think there's a choice here. Would you agree it has to be 14 to the n? There's really nothing else to pick. But if there was a choice, don't you pick the bigger of all the things that it could be? Right, so if there's a 3 to the n, a 10 to the n, and a 14 to the n, don't you still pick the 14 to the n? Now in this case, it now becomes the limit as n tends to infinity of 1 over 14 to the n plus 1. And I can do brute force that then. It's 1 over infinity plus 1 1 over 0 plus 1 equals 1. Have you noticed that an awful lot of these questions, the limit ends up being 1? Don't get into the habit that the limit is always 1. It just happens to be that that happens a lot. And by the limit comparison test, then it converges. And the reason it converges is because so does that prime. Right, that one was a bit quicker, but we're getting comfortable with the process. That's what I want to make sure we are. So to finish limit comparison tests, at least for this part of the time, where is it? Here we are. Let's look at a limit comparison test from Hades. And I am only going to take this question to the point where we know what it's going to do. In other words, I'm only going to do the surgery. I'm not going to take it all the way to the end. And I would never give you a question in the test where you would do this all the way to the end. Right. But I might ask you to show me its comparison series. Whoa. Now, if you're really brave, you can do this in one big go. If you're not, you have to do some more work. So if you want to do it the long way, couldn't you FOIL that guy out and then figure out which the biggest power of k that would be there? But can't you look at that and tell me what is the biggest power of k you're going to get in this question after you FOILed it, just by looking at it without doing it all? Would you agree you get 6k cubed? Can you see that? I mean, if not, FOIL it out and you'll see it. I'm putting the 6 in, you don't need to. You can just put in the k cubed and it's okay. And this one might catch you out. What do you get on the bottom? What single power of k ends up on the bottom after surgery?
Is it
A to the 5th.
I heard it in 3 different places. 1 I saw and 2 I heard. You nailed it. Which means, isn't this guy going to behave like a 6 over k squared, right? Now, if you don't like the 6, it's totally okay to just call it 1 over k squared, right? Because constants don't matter. Would you agree that is a p series? Back to p series. That the p is equal to 2. And since that's greater than 1, aren't we looking at converges? And when you get your version of that in question 9, will you just stop there? So I'm actually telling you to do what I normally tell you not to do. Wouldn't I normally say, okay, you know it converges, but now prove it? And that I would definitely want you to do in all the other situations. But in this one exception, can we just skip to, because the answer just has 2 circles, right? Converges and diverges. So you can finish there for that one. Because it's kind of impractical. Can you imagine how ugly that math is going to be if I did the next step? I mean, we'd be here for another 20 minutes just figuring it out, because there'd be so many things to factor and cancel, and who knows what would come after that. So in this case, we are good. But do not do that in any of the other ones, right? That's a special case.
I did do that one last night and it was pretty brutal. There was a lot of workings before I got to the end.
Oh, I'm sorry you did that, Kira. But I mean, it's good practice. I mean, I'm not saying it's bad for you. What would you say it would take? 15 minutes? 10 minutes? What would you say?
Yeah, something like that. It was just a lot of foiling mostly. Once you foiled it all out, it wasn't nearly as bad.
Right, it's just ugly and massively big. Would that be a fair description of it?
Yes, for sure.
Yeah, right. So, So the reason I'm skipping that is not because it's hard, it's just painfully annoying to do. I'm looking for, oh, it's up the top. So the next couple of questions are still going to be on limit comparison test, but I'm changing my mind here. I thought I had one to see. Maybe it's at the bottom. No, their video's at the bottom. No, it's not it. Okay. Then, since I can't find it, I will just show you it, right? Oops. You have 1 over two squared plus 2 over 3 squared plus 3 over 4 squared forever. And the question is, does this series converge or diverge? Now, what makes this different from any of the other limit comparison test questions is we don't have a sigma an to work with. So don't we have to create that? And we've done that before. So number 1 gets you this, number 2 gets you this, number 3 gets you this. So what would an be? The individual term. I need a formula.
N over n plus 1 squared. With parentheses.
Yes, I agree, Stephen. Does that make sense? Are you comfortable with where that came from? The more you do, the more comfortable. So we are essentially just going to be finding that guy. And if it makes your life a little bit easier, it's basically that guy. Now, at this point onwards, isn't it just a limit comparison test? And so I'm not going to finish it. Right. So you may get, I just can't seem to find them right now. I don't know why. You may get a question where you're being asked to find out what this is, converges or diverges. So you have to find the individual term formula and then plug it into the series that it comes from. Just looking at that one, can anybody tell, because we've done so many of them, is that one going to converge or diverge? Just by looking at it.
Diverge.
Correct. Kyle, why? You're right. And you could be guessing, but what was your thought process? Sometimes it's hard to say.
The P would be less than 1, effectively.
Yeah, isn't it a 1 over n, essentially? And what you said is correct, P is less than 1. So when I do these guys, do you know, I can look at them pretty much right away and tell whether it's going to converge or not. And then the rest is the math to prove it. Suppose, just to give an example of how you could do that. That one converges. What's it behave like? How do I know it converges? What's the surgery look like?
N squared over n to the 4.
And isn't that 1 over n squared? And that's why it converges. You know, so when it's these guys, you can basically just cover up the ends and look at the beginnings. And isn't that 1 over n squared? And that's a converger. Okay, that's everything, definitely everything I want to do with that. Now we're just going to do what's called the comparison test. Oops. And I did say it when we started this, that once you see the comparison test, you will want to use it for every single question that we've done in the last day and a half, right? And you're not allowed to, because half the time it doesn't work. In other words, you get the answer and it's wrong, right? And only use the comparison test when you have weird stuff, I think I called it weird stuff, you know, things like that. You know, things like that, right? Sines, sine squareds, e to the 1 over n's, e to the sine n, right? Weird stuff, right? Whenever you see, and there's typically going to be a polynomial on the bottom, right? An n cubed, an n squared, and stuff on the bottom. Put an n on that just to show you it doesn't need to be one term. And in those cases, and only those cases, you should use the comparison test. And here it is. If sigma Bn is a convergent series, and An is less than or equal to Bn for most n's. So you're allowed to not work for the first couple. If An is less than or equal to Bn, then sigma An also converges. So the comparison test says, you know, Bn is the surgery guy that we talked about earlier. This is going to be a different version of it. If that guy is a convergent series and our original guy is always less than or equal to it, then our guy will converge. Does it make sense if this adds up to 50 and this series is made up of things less than that guy? Won't this guy also add up to a number and so must converge? Right, that's kind of the argument. Now, there's two versions of it. If sigma Bn is a divergent series, and An is bigger than or equal to it for most n, what conclusion do you think you're going to make about the series An? It's bigger than a divergent series. So what do you think sigma An is going to be? Convergent or divergent?
Divergent.
Yes. If you want to take all of that and kind of write it in a kind of English sentence, if you're bigger than a divergent series, you diverge, and if you're smaller than a convergent series, you converge. That's essentially what that says, isn't it? If your guy is smaller than a convergent, you converge. If you're bigger than a divergent, then you diverge. And so we are going to have to do a different kind of surgery to come up with this Bn guy. Now that Bn guy is going to be a P series most of the time, and now and again it's going to be a geometric, but for the most part it's going to be a P series. So let's give you an example of one. Let's do the surgery on this one, but it's a different way that we set it up. We don't do the little squiggly lines. First thing is, for some people, a little bit tricky. I have to know whether this guy is going to converge or diverge. So I kind of have to know what the answer is going to be before I prove it. And it's not as hard as it looks. Would you agree that the sine of n varies, but isn't the sine of n not huge? The biggest it's ever going to be is 1. Would you agree? So won't the biggest the top ever be is 9? And isn't 9 over n squared a P series that converges? Does that make sense? So I know that this is going to converge. So I need to make sure that it's less than or equal to what goes here. And I've already kind of answered that. Isn't this guy always less than or equal to 9? And isn't this a P series? And it's a P series. and P is equal to 2. And since that's greater than 1, it converges. Almost made a mistake there. Do you see how quick that test was? No ratios, no limits, no horrible foiling things, cancelling things, L'Hopital things. I mean, I don't know. It's hard to put a number on. Would you agree it's at least a third or a quarter times as much work, right? It's that 4 times easier to do. Can you see why there's a great temptation then to do it everywhere? But it should only be used. And by the way, this is question 17. This one is question 19. Oh, goodness gracious, look at that ugly guy. N to the power of 1 plus 1 over n. Agree? Now, who do you think this guy behaves like? What P series do you think n to the 1 plus 1 over n behaves like? Right, you agree it behaves like n to the power of 1, right? Or 9 over n to the power of 1. What do you know about 9 over n to the power of 1? P series, isn't it? And it diverges. Agreed? So you really just need to look at this guy. This is a P series. P equals 1. Diverges. Let's try.
Can't you also do that one quite simply just by the divergence test?
Oh, goodness gracious me.
Wait, oh, no, you can't. Never mind. Because n would be infinity there. Never mind.
Yeah, okay.
Yeah.
For a minute, I thought you were right, but
If it was just n to the 1 over n, then
if it was that guy, then the divergence test would have got it, right?
Yeah.
I think actually, now you've said that, there is a divergence test one floating around here somewhere, if I can find it. I could be wrong. Ah, here we go. That one is not a comparison test at all. That one is a red herring. And that one happens to be question 12. Oops. Take that back. That one is not a comparison test at all. That would have been, which is where my brain was. Okay. Let's do that as a comparison. Would you agree that that guy is less than or equal to that guy? If you picked 5, wouldn't 1 over 5 to the power of 5? Well, that's actually, that is true, isn't it? Yeah. 1 over n squared wouldn't be near as bad as that. Let me check that. Small answers on the bottom. 5 to pi to 5. Ooh. I better think about that one a minute. Is that true? I mean, if it is true, it converges. Agreed? Because it's smaller than a convergent. Is 1 over n to the n less than or equal to 1 n squared? Let's pick up. Is that guy less than or equal to that guy? He's not, because that's small and that makes that big. Oh, I have to find a comparison for this guy. Oh, that's cool. I'm having a quick look to see what their comparison is. Right, for our last question for today.
Could you maybe do something like 2 to the n instead of n squared? Because then the other base would get bigger and then that base would stay kind of the same.
See what that looks like. So when n is 3, is 1 over 3 cubed bigger than that guy? Nah, that's going to kill it. This is a good one. I do not know the answer. I'm going to look at the answer and get
Could you
really
do
annoyed.
it to a negative power?
Oh, come on. That's not true. They said that that's true. In which case it converges, which is what I said at the start. And then I talked myself out of it, but I don't think that is true. Which means that they've made a mistake, not me.
It seems like the only thing that would disprove it is a number less than 1.
Yeah, and when we do the comparison, it's to be for ever, right? Like, okay, the first 4 or 5 don't matter, but after 6, everything bigger than 6, this has to be true. And I don't see that as being true. I'm looking at the answer and they are saying that this is true. Okay, let me try it again. Maybe I can't count. I am looking at that guy and I am looking at that guy. And if you take 1 and you divide it by 5 to the power of 5, you get 0.0. Oh, darn it, it is true. I didn't calculate it right. Ah, perfect. If you're less than or equal to 1 over n squared, aren't you a converger? Because it's a p series and off you go. That question, I made a meal of it. Actually, isn't it also less than 1 over n cubed? I could have picked anything as long as it works. And that's going to be us for today. And we still have a couple of tidy up questions. I want to do those and then we'll call it a day and move on to our last section. So put your name down, your last name, and you're out of here. I'll see you tomorrow. I'm really annoyed at that 1 over n to the n. I should have stuck to my guns the first time.
I had a quick question for you.
Yeah.
For the comparison test, will we ever find like an actual number for it or just if it converges or diverges?
Right now, the only thing that you're dealing with is that it converges or diverges. Now, can you find an exact number for it? Well, not an exact number, but we can do an estimate. And the estimate is going to be pretty crude. Just find S10 or S200. And if you were there, they don't go this far, but suppose somebody said, but I don't want to know the answer like that. I want to know the answer at least plus or minus 0.2, you know, that kind of thing. Well,
Gotcha.
what you do there is you write a little program and you get it to do S20, S21, S2 on 1. And when 2 answers agree to plus or minus 0.02, whatever you wanted, stop, you found it. But totally numerical, right? You wouldn't really do it by hand.
Okay, awesome. Thank you.
You're welcome. Okay, any questions? You are bye-bye then.
Professor.
Yes.
I'm kind of confused on how you find AN for the comparison test.
How do you find AN? Right. You really look at the thing, the original, and you try and do like a surgery trick that we did with the other situation. So I'm just randomly picking some guys and seeing what I've got. Suppose I had sine squared n plus 1 over n cubed plus 1, right? Would you agree that sine squared never gets bigger than 1? And so I would say that top is about 2. And would you agree the bottom is n cubed? So I would be looking at a P series P equals 3. Right. And then all I need to do now is to prove that this guy is less than or equal to that guy. But I may have to tweak this. If you make the bottom smaller, right, don't you make the fraction bigger? So what you do is you do a little bit of surgery, you give this guy a multiple. And so I can prove that that is true. In other words, 2n cubed is bigger than n cubed plus 1. Because 2n cubed is bigger than that, won't this be, you know, the one? If that doesn't work, the other thing you do is typically you stick a half in it. In which case it would be that. So that's the one I would have chosen in this case. Is that what you were looking for?
I'm still a little confused, but I think I'll be able to figure it out though.
Okay, let's put some guys in here. E to the 1 over n plus n over n squared plus 1. Let's just do the surgery, what it behaves like. Bottom behaves like n squared. And that's definitely n. What does e to the 1 over n look like when n gets really big?
That'd just be E.
Well, e to the 0, and e to the 0 is essentially 1. And then can't I do a little bit more surgery and do that? And then that's 1 over n. Do you see that I now know that this guy behaves like a version of 1 over n?
Yeah.
And since it behaves like a version of 1 over n, don't I just need to prove that this guy is bigger than or equal to 1 over n? Or if I need to, a half over n or something like that, just to make sure it works. As long as I can get a multiple that works, I'm good.
So you can like kind of interchange the factors of the different variables.
Well, you can simplify them down by only picking the important pieces of them. So in n squared plus 1 isn't the important piece n squared, for instance.
Okay.
Right.
That makes a lot more sense.
Yeah. Any other questions, guys?
I just had a quick question about question 15 on the homework.
Have you got it handy for me? What does it say?
Yeah, so basically the question I have is kind of near the end when it does the limit of, and I'll just read out the condensed version. It would be n to the 4th plus 2n cubed on the top. And then the bottom would be in parentheses n plus 6 to the power of 4, at least the version I have.
That guy?
So so as I was thinking about trying to solve that, my first thought was to go and divide both the top and the bottom by n to the power of 4. My question is, I mean, logically, if you think about doing out that whole foiling the bottom, all you're going to get is 1 plus a bunch of different variations of 1 over infinity. So like, but that doesn't feel very mathematically rigorous. That just feels like logically jumping to the next step.
Okay, so let me try and make it mathematically closer, hopefully. I'll do the divide top and bottom by n to the 4 method. So that's 1. That's 2 over n. I think we're probably happy with that.
Mm-hmm.
Since this is a power of 4 and this is a power of 4, can't I just divide what's inside by n?
Oh, that's how it would be.
And so
Okay,
you would just get 1 plus 0, 1 plus 0 to the power of 4, but that's just 1 over 1, so it's still 1.
I'm still not in the habit of combining powers like that. I think that's the part I keep like missing on those.
Okay.
Okay, that makes sense. Thank you.
Right. It's really helpful when they do that to you.
Yes, because suddenly it makes a lot less sense to try and think even close to foiling.
Yes. Gotcha.